And now we'll dive into our final session of the day, which is focusing on what is enabling that ecosystem, that decentralized data ecosystem, and the different protocols and technologies behind it. I would love to welcome our first speaker on board, Yaniv, who is the founder of the Graph Protocol. Yaniv, over to you.
Hello. Awesome. Excuse me, I've got a bit of a cold, but excited to be here today. The title of this talk is Making Open Data Rain, which I thought would be appropriate given I heard we had some rain here yesterday. I'm the co-founder of the Graph. We're a query protocol for Web3. And Web2 has been developing over the last 15 plus years, and it's become pretty mature. People are building really great quality applications. You use them throughout the day on web, on mobile, on all your different devices. And we've gotten to a point where the technology stack itself has kind of started to mature and ossify. People know how to build this stuff. And what's happened is a lot of the early companies that built a lot of these applications that we use today have started to grow into these monopolies. And the way that this architecture works, the data is tied and it's combined with the service such that once you use one of these applications, you can't easily switch between them. And this is what creates this kind of monopoly power, and this is what gives these Web2 companies their monopolies. And so, at this point, we're seeing this drive from developers and from a lot of people that want to basically take the software and all of the learnings that we've had about how to build for the web and basically commodify it to push a lot of the innovation down to be like a public utility that that anybody can use, not just these giant companies. And this transition is really important because the software that we use is responsible for more and more parts of our lives. There's decisions that the software is making that we don't even know, how the logic is programmed, what decisions these companies are making on our behalf, and if we want to, solve a lot of the big problems that are facing humanity today, we need to have a solid foundation for software that we can trust and build upon without giving that power away. So that's what Web3 is all about. And at the core, Web3 is about building software on top of protocols that have these properties. They're open, which means that anybody can participate. You can build software that plugs into these protocols without having to go to any gatekeepers. They're secure, which in most cases means Byzantine fault tolerant or roughly resilient to malicious actors. They're stable, which means that you can build software on top of them without having that software break. There's no more of these kind of breaking changes, which the way that most software is built today, it's very brittle and doesn't have this property. And finally, it's verifiable, which means that even if I'm not running the server that's running the software, I can check for myself that all of the properties that I care about were upheld. So these are the main properties that we want in our protocols, and if we build software on top of protocols that have these properties, then we can say that we're building on a solid foundation. From a data perspective, what this starts with is value-oriented programming. We were heavily inspired by Rich Hickey and the work that they've done on the Datomic database and closure programming language. And the principles of immutability were around way before blockchains. Immutability is a core concept of functional programming, which is really a way to just build software on a solid foundation. And it starts by using things like content addressing. So on the web today, things are generally identified by names like URLs or database IDs, things that are constantly changing. Any database that you use today, if you have access or you have a reference to a row, you don't know what value is at that row in the database. It can change under your feet, and that makes it really difficult to build reliable software. And so in functional programming, you use things like persistent data structures or content addressable names, where given an address on a protocol like IPFS, you're always going to get the same exact data back. You know exactly what that data is referring to, and that's a really important building block. Then on top of that, you can layer in things like consensus. So one way to think about consensus is it's a way to update these, this global state that's persistent and immutable without having a single operator that's in charge of deciding how to make that update. So, problem with immutable data structures, things that can't change, is obviously the world's not static. Things do change. And so you need a way to update the state. And at its core, you can think of consensus as being a way to update that state without, crowning a single privileged party. And there's a few popular consensus algorithms that people are using for things like Ethereum today, but there's a lot of experimentation here, and there's going to be more than just a few of these. It's a wide trade-off space, and those two pieces together kind of form a sort of foundation for the bottom layer of the stack for how we reference data and store data, and that kind of acts as a foundation. So with that, we can look at the architecture for Web3, which is how we're going to be able to build all of these applications with the properties that we wanted. So at the bottom, we have these infrastructure protocols. And this is kind of the bottom of the stack. So there's blockchains, which we talked about a little bit, storage networks like IPFS, but many more. And these are like the low-level primitives on top of the hardware that you need if you need to have like low-level computation in order to be efficient, or you need access to special hardware, anything that's kind of special purpose, then you need an infrastructure protocol where people can run these nodes. These nodes can connect together. They can provide guarantees, and they're running in this kind of decentralized network. So the graph is one of these. We do indexing. There's many others that tackle different parts of the stack. Then on top of those infrastructure protocols, you have logic protocols. And these are, for example, things that you would build using smart contracts, say on top of Ethereum. So if you have like a blockchain that supports smart contracts, which is just generalizable logic that runs on them, then you can start to encode a set of rules for how to do how to solve some coordination challenge amongst a group of participants. And we believe that in the future, most of the logic that kind of runs on the server is going to run in these sorts of logic protocols, right? This way, the rules of the game are open. People can inspect them. They can know, what are the rules. They can make changes to those rules, and it creates this openness and transparency, which is really important. So a few of the core logic protocols that are being worked on now are things like governance. So we've got projects like Aragon and DAOstack and Moloch and many others, just trying to solve the problem of how do you, for example, coordinate funding and take on projects that you want to accomplish as a group, and how do you vote on which proposals to actually implement. We've got things like identity, which you may want to have be anonymous or not. Financial primitives, DeFi or open finance is really popular area on top of Ethereum right now. Marketplaces, all of these are examples of logic protocols that you can build on top of blockchains. And then once we have a lot of these logic protocols built, we're going to see an abundance of open data. Right now, most data that comes out of these Web 2 applications are siloed, they're trapped. They're not things that, as an end developer, you can access unless the company decides to open it over a public API. In Web 3, all of this data is going to be public and open and available. And what that means is that as a developer, you'll be able to just plug into this global data stream to build whatever applications you want. And so a dApp is what sits on top of this, and it's just an application built on top of these decentralized protocols. It has the guarantees that we described, and if you use a dApp, you know that any investment that you make into an application, you'll be able to take with you to the next application, right? And this is pretty profound because right now each application really is kind of an island in and of itself. It's kind of like early primates before the invention of language, right? Before language, if a primate died, all of the knowledge that they acquired over their lifespan died with them. And then once language was invented, suddenly knowledge could be transferred from generation to generation. It wasn't gone with the passing of a single generation. And so similarly with Web 3, anytime you use an application, that data can persist, and you go from having these hundreds of thousands of these independent siloed machines, each one that lives and dies with the lifespan of that individual project, to having this global giant machine that persists and is available to all. So now I want to talk about the graph, which is, as I alluded, an indexing and query protocol for organizing all of this open data on Web 3. And so the problem that we solve is that you can have data in these storage networks and blockchains, and those are really great ways to store the data, but they're not efficient ways to access and retrieve the data. And if you try to build an application directly on top of a blockchain like Ethereum, you quickly realize that you can't actually get the data that you need back efficiently. And that's because there's this missing piece of the stack, which is this indexing layer. So indexing is basically a way to organize data so that you can efficiently retrieve what you're looking for. And that's the part of the stack that we're building at the graph. So it roughly looks like this. You've got the underlying data sources on the right, so that could be blockchain storage networks. They trigger events. We have a graph node that runs and processes those events, has access to that data, runs arbitrary data transformations on that data in a WASM VM, puts that data into a store, and then serves it up over a GraphQL API. And so as a dApp, you can query all of your data flexibly over this GraphQL API. Which is really fast and efficient. So we open sourced our first version of our graph node early last year, and just in January we launched our Graph Explorer, which is a place where you can go find all of the data that's being indexed on the graph. So we launched with some initial protocols, and since then we've had a bunch of different projects building on us, deploying new things to the graph every day. So each of these is called a subgraph, and it defines how the data is indexed, transformed. It's basically like an API to some section of Web3. If you check out, for example, the Moloch subgraph, so Moloch is a DAO for funding Ethereum infrastructure. So if people have some idea for some cool new infrastructure piece to build for Ethereum, they can apply for like a grant, and all of this data is being indexed on the graph. So if you check out one of these subgraphs, you can go through and see, for example, the shape of the data, and then this on the left. I don't know if you can see this. I guess you can't. So this is GraphQL on the left, and basically it's a way to specify what data you want to fetch from the server in a really convenient way for building front-end applications, whether it's like on web or mobile. And you can seamlessly traverse across these entity relationships. So if you have these, like a data model where you have different types and they relate to each other, you can seamlessly traverse those relationships and get just the data that you want back in a single request. And so as a developer, if I'm trying to build like a web or a mobile app, I can very easily discover to see what data is available, and then compose my query, run it, I get the data back exactly the way that I asked. And with the graph, we set up this public HTTP and WebSocket endpoints that you can hit directly from your front-end applications. So right now, there's a lot of projects that are using the graph. There's subgraphs for governance protocols, DeFi protocols, really across the entire spectrum. And what we're doing is, we're starting here, and we're just going to keep adding more and more data to this graph. Right? All data is essentially relational. Right? If I have an organization has members. Right? Those members maybe completed tasks. Those tasks, maybe had some output related to another project. And so all data is kind of related. And when you start by defining data in terms of these immutable data structures, things that persist and don't change under your feet, and you just grow this graph of data, that's going to create the stable foundation that anyone could build applications on top of, and you'd have guarantees that those applications will continue to run no matter what. So that's what we're doing at the graph. That's the vision that we're excited for Web3. And thank you so much for having me on.
Thank you. Thank you. I would love to announce our next speaker, Dimi here, who is the co-founder and head of research at Ocean Protocol.
Watch the cable. All right. Oh, cool. Okay, and then we have this. Hi, everyone. Since it's one of the last talks, I thought let's keep it light a bit. I'm going to speak a bit about what's behind what we call a public intelligence network, and how does this manifest? Why are we building this? And maybe a little bit of nerdy details as well, but that's cool. So you could say that there's a lot of problems, and we're working mainly with things like AI for good, sustainable development goals of X prize, etc. And they all want to have more data, but it's kind of hard to source that data. On the other side, and we have something called the Commons Marketplace, which is a data marketplace. It's all for free and interesting data sets about healthcare, smart cities, automotive. It's all there, but they're kind of looking for problems. And I guess we find ourselves somewhat in intermediating between those two. Not only intermediating, but also creating like a kind of a mutual magnet. Problems finding data, data finding problems. But the real reason that I personally got involved is because I want to create something weird. Let's call it a self-owned autonomous agent. I call it the Dalai Lama. It's a taker of data, so it needs data and services, and it's a giver of arts and love and coins and tokens. It's pretty, and it even has a Twitter account, right? So how do we make this self-owned agent something real? Well, first of all, it needs to be able to have visual recognition. So you would look into convolutional neural networks and maybe something that they call long short-term memory arrays, and you can start doing object recognition. You can auto-caption images. And the more data you get, the more rich your set becomes. What if you train this on ImageNet and other things? And you can immediately see that this could also apply to, for example, healthcare. My colleague Franz was talking about anomaly detection in X-rays. So if you have like a highly trained neural network, maybe that can also apply to medical use case or autonomous driving. Huh? So, but you also kind of want to hear, for example, getting speech input or textual inputs, process that, start to communicate with humans and other agents. And then maybe you also want to generate new outputs and messages. And then you create something that's actually becoming your friend. Like, Dalai Lama can talk to me. Oh, so fun. But what if you have a Dalai Lama, right? And then you can use like generative adversarial networks, GANs, and it would create arts. And it would not only create arts, it maybe also creates new designs, fashion designs, etc. And here it starts giving. It starts giving to you. Well, what it actually is, and we all kind of are, it's a data service supply chain. So, what is that? Well, it's a supply chain of services. You typically would take an algorithm, you could push it to a data set, there's things like federated learning, etc., and then you would start computing your algorithm, training weights, etc. You would store the output result, which then would be deployed in an operational setting, being your algorithm at running. And then you can use that algorithm maybe in other contexts. There's things like transfer learning that allow you to take a neural network, cut out the output layer, and use it in a very different context and retrain it. And you can start stacking algorithms. Really neat. And you can also think about curation. What's the relevance of data applying to algorithms? What's the relevance of algorithms applying to data? Different verticals, different use cases. But we're trying to be more generic. But there is one problem. Let's say our Dalai Lama has like this nice pool, this ocean of data services, and suddenly he goes there and sees, oh, everything is dried up. Well, so he tries to track the source of that plenty of water and ocean, and it finds that there is a central information acquisition organization, let's simply call it a CHOW, and it built a wall, a silo of data. And that's not something our Dalai Lama becomes happy about. So, luckily, there is something that they call the Department of Decentralization. You can see Dalai Lama is part of that. This is something that's happening in Berlin, by the way. You want to go there, it's very neat, and they know how to treat the chow. So we're looking at a decentralized version of these data service supply chains, right? So that looks a bit like this. You have service pools, you have data pools, markets. You have ways to connect these. And Ocean is not a single service, it's flows. Connects services to each other, creating more and more intelligent agents. Soon you'll see a Fetch, which is a sister brother company, however you call it, and they're assisting us creating these autonomous agents, smart discovery, etc. So we're really focusing on how can we get algorithms from a market into data from another market. Does it have to be a market? Maybe it's more a community, maybe it's more an organization, maybe it's a decentralized organization. So we're not defining what application you're going to run on it. We just provide all the infrastructure to do that. What's that infrastructure? Well, that's a protocol stack. Oh, the protocol starts with discovery. Like, yeah, you have your Dalai Lama. Now you want to know, well, here's my profile. I'm going to publish this on some market. And he gets an identity. Everything in Ocean is an identity. It's a service, it's an identity. Data is a service, data is an identity. Identities can become governed. can hold funds. They can give incentives. And we also, in our past, we created something called BigChainDB, and even the graph would be very useful for us to make a metadata store where there is fluent discovery of, well, I have a problem, I have an algorithm, I want to find data. Check, check. And you can publish this in any type of setting, fully decentralized. We'll have many of these. And we can do a search across all of them. Well, another thing, well, we're not saying that problems should be looking for data. We say that data should actually be looking for problems. How does that work? Well, we start with an initial problem, like we have an actual use case running to measure lung capacity from X-rays and also anomaly detection. Now, we try to incentivize a community to work on this, to give better data, better models. So you create something called X-ray net. I'm just giving this an arbitrary name. We could be cooler. But there's other nets like ImageNet, WaveNet. And these are communities nurturing a data set. They can become governed, they can become tokenized, and then they'll signal their relevance to new problems, saying, hey, I'm very good at object recognition. What other problems can you throw at me? Now, the crucial part, the thing you really want to get straight, is access. Let's say a private data set and an algorithm, they walk into a bar and they have their first date, and it's a bit, a bit creepy. And data provider says, my data shall not leak. I want to keep it for myself. I do want to interact with you, you algorithm, but I don't want to expose myself. First date, you know. Well, would you run my algorithm on your data set and just throw me back a result? Well, maybe you can do that. So what happens, now this algorithm gets pushed into that data center. The data owner is in full control. Does he want to run it or not? Does he want to earn some tokens or coins or not? But it's in full control. And we can have other scenarios, right? Negotiation. So we created something. Well, first of all, our premise is data doesn't want to move. There's privacy, there's just largeness of data. So we bring the compute to the data. And that's what you will see in federated learning. You could say, arguably, you could say that we're creating something like tokenized federated learning. Hey. So we created something which we call access policies. And these access policies are smart contracts, but they're super modular. You can say, under these conditions, you can access my data. And the cool thing is that we deploy them in a way that you can describe, like, if you give me access, I will reward you if somebody else proves this, et cetera, et cetera. You create like a structural language around this access policy, and the smart contract will be there to gather information about, did you provide all the proofs you need? Did you do your actions correctly? What's the rewards we're going to give you? Is there some kind of dividend we're going to give back to the community? So it's very flexible, very modular, and we call it service execution agreements, only because we can then shorten it to Cs. And remember, we're Ocean Protocol. And in the end, this is the last slide, well, we also have network rewards. We want to incentivize good behavior, but everybody could incentivize good behavior in your service agreement. So we created something, a reward chest. And then we have governance on this reward chest that leads to different types of lotteries. If you contribute free data, you get token. If you solve problems for AI for good, you get token. If you contribute code to our community and our protocol, you get token. Everything could be bountified. Everything could be part of our community. So that's kind of what we're doing. Now, we have ways to engage everyone. Just start with our GitHub or our web page. We also have something called, I think, commons.oceanprotocol.com, and you can kind of play with one of the first apps we put on top of it. Yeah, it's a lot of fun. So, thank you.
Thank you. Well, that was fun. You've managed to make very complex things sound very, very simple and very fun. I would love to introduce our final speaker in this session before we move into the panel, Jonathan. Please take over.
Can anybody hear me? Okay, great. So my name's Jonathan Ward. I'm head of research at Fetch AI, and as we mentioned earlier, so we're building a platform for the deployment of multi-agent systems. And one of the things we want to do is, in creating that environment, we want to build collective intelligence. And what I'm going to do today is just outline the kind of vision for Fetch and a couple of the mechanisms we're using to build these kind of decentralized collective intelligence. And one of the ways I'm going to talk about it is there are lots of analogies between the way human economies or human individuals build collective intelligence that we can actually apply to the digital domain. And I'm going to outline how we're going to do that. So just to give a bit more background, we are actually a fully integrated blockchain platform. So we are actually building a scalable, sharded blockchain with a new consensus algorithm. We intend its performance to be overcome some of the major issues with blockchain technology in terms of cost, in terms of efficiency, etc. And the main differentiating factor that we have with other existing protocols is that we have a platform for very high performance smart contract technology. And through that then facilitates all of the technology that the stack, which is involving the deployment of multi-agent systems, that we wish to facilitate. Okay. So one way in which, so just to clarify, so there's been some debate about what the role of agents is with respect to data. Agents actually take steps in the world that modify the state of the world. So they actually act on your behalf and modify the state of the world. They are not static data. That is the key difference between an agent-based system and a decentralized data marketplace. Okay, so what we know is that if the 20th century was characterized by Moore's law, the 21st century is really going to be dominated by edge-based computing. So these are ubiquitous networked devices. And what we also know that all these devices, there'll be 20 billion of them deployed by 2020, are generating absolutely enormous amounts of data. And it's absolutely completely impractical to see any way of centralizing that data anytime soon. And the vast majority of it that goes through your smartphone or your smart connected home is actually not stored or used in any way. So there's a huge opportunity for monetizing that source of data. So what we know is that obviously our mobile phones have become the kind of hub of our digital life, and we use that to interact with other kind of elements of our lives, which include cars, automotive, and smart homes, also facilitated by the cloud or the internet. However, there is a limitation to that, and if we take the limitation to the fully connected world is where you have a situation such as smart energy. So in this case, we might have solar panels or wind turbines, and we might want to be able to share resources between different people. The issue that we have here, though, is that we have multiple stakeholders. So the connectivity and the network devices themselves don't provide the full solution to this problem. Okay. So there's an obvious solution to that, and this was one that was actually mentioned by Milton Friedman almost a full decade before the development of Bitcoin, was that the possibility of, through the internet, developing a reliable e-cash system. And he also anticipated it being decentralized and to some extent anonymous. So if we then augment this picture with the blockchain technology, which provides a means for financial exchange, we then have a huge amount of additional market mechanisms that can exist and greater potential for efficient allocation of resources. Okay, so as I said in the start of the talk, so what we're dealing with to a large extent is complex or distributed systems, so there's no feasible way of centralizing them, and they involve multiple stakeholders. Now, as it turns out, this, as a field of research, has been studied for a very long time. And what you'll also get from looking at these two definitions is that actually also covers blockchains themselves. So the fact that we're actually thinking of blockchain as a multi-agent systems is one of the reasons why we have an advantage in terms of building a more efficient blockchain. Okay. So the question is, how do you build decentralized collective intelligence? One way is by decentralized decision making. I'm not going to talk about that today, but there is lots of examples of that on our website, really interesting ones around cars and vehicles. The other element which I am going to discuss in more detail is something called prediction marketplaces. And the idea here is, so there's definitely analogies with how collective intelligence is built up in the human domain. So what I'm going to talk about here is an observation by Sir Francis Galton around the 1900s. So he was probably the world's first data scientist, statistician, unfortunately eugenicist. And he was attending a farmer's market, and what he noticed was there was a competition going on where the goal of the competition was to guess the weight of the ox accurately. And what he actually found, to his enormous surprise, was that the average estimate from the crowd was extremely accurate, very, very close to the actual weight of the crowd. And that was totally against what he anticipated, because he anticipated that there was going to be some genius like him who was going to be able to do better than any collection aggregate of individuals. And what we actually see is that something like the efficient market hypothesis and the way stock exchanges work, the reason it's so difficult to make money in these contexts is that they are actually aggregating the knowledge of many, many people. So the question then is, okay, so this can work well for building collective intelligence, but there are definitely situations where this fails, right? So we all know situations where collections of people can behave much worse or much less cleverly than any individual. So the question is what are those different components? And they've been summarized in this book, which I can strongly recommend. And those are that there needs to be a diversity of opinion, so there needs to be lots of people making a prediction. They need to be independent, so they're making their predictions independently of each other. Ideally, they need to be decentralized, so this means they need to be as diverse a group of people geographically separated. There needs to be a way of aggregating that information between all of those different agents. And there needs to be some way of establishing trust. So this is a way of ensuring that they have confidence in the way that the system works, and also having limits on their behavior. So there is actually an analogy for this in machine learning. So what we know from machine learning algorithms, I'm not going to go into too much detail, but a fundamental problem that you face in machine learning is that if we want to fit a model, which in this case is modeled by the green line, and we have some noisy data set, fundamental problem is solving the trade-off between model complexity. So in one case, you can imagine having the yellow line, which is a model that's too simple, can't fully represent the data. In the other example, in the red case, we have a model that's actually fitting some of the noise. So it's not going to generalize well because it's not representing the underlying trend in the data. It's just fitting some variation. So what we know is that if we take a very popular machine learning technique, this is a decision tree, which basically just splits the data set up using a very, very simple set of criteria, that is very, very prone to overfitting. However, if we aggregate the results from many, many, many instances of these prediction algorithms, what you actually find is that you get a much better algorithm. So all of the noise, all of the fitting of the variance works out, and you end up with a very good result. So what we actually find is, if using analogies with machine learning, there is diversity of opinion, independence, and decentralization. And what we know is that ensemble machine learning methods already work better. So if we apply these techniques to the machine economy straight out of the box, we have a technique for aggregating information from many different sources. The only thing that we need to do as the platform is to supply the other two components, which are a means for aggregating the predictions and a way of assigning trust. And I'm just going to very briefly outline the techniques that we're using to do that. So obviously what we have is a decentralized network. There's an option for things like sovereign and identity management. So there's a way of maintaining reputation or some kind of persistent identity on the network, which is important. The other thing we can do is say, okay, well, we need to specify some kind of event that's of interest to people, which we want to make a prediction of, and say, as an example, given that it's rained a lot today, is whether it rains tomorrow. And what we can then do via the Fetch platform is specify a smart contract. And what the smart contract can, for example, do is I can sell you, for $1, a pair of contracts, A and B, and contract A pays $1 if it rains tomorrow, and contract B pays $1 if it doesn't. Now, if you buy both contracts, you've paid $1, and you basically got something that will pay you back $1. But once you have these pair of contracts, what you can then do is go in the market, and if you think it's definitely going to rain tomorrow, you're going to sell your contract B, which says it's not going to rain. And in that way, you can specify a market for what's going to actually happen. And this is a way that people can go into the market and obtain predictions from multiple different devices, aggregate that, and obtain a prediction that's of interest to them. Okay. So obviously, I don't have much time. So I'll just go through that. So obviously, we're an open source platform, really interested in getting people involved. There's lots of tools for developing the smart contracts, really expressive smart contract technology. We had a major code release yesterday, Project Andromeda, with lots of new functionality. We also are providing lots of tools for actually building and deploying agents, which you can use to monetize different resources or also operate on your behalf. And with that, I'll just end with some further information and just a statement. If anybody's interested, we're very interested in hiring. And thank you for your time and any questions.
Fantastic, thank you very much. And Joon, who's a managing director of Consensus, will now moderate a panel discussion with the speakers just before.
Yes, thanks very much.
Would love to introduce Dave.
Well, first of all, can I have a big round of applause from the room? And that's mainly for you guys, because we're the last thing standing between you and a drink in the sunshine. So, well done. You know my panelists, Yaniv from The Graph, Dimi from Ocean, and Jonathan from Fetch. I'm with Coindesk, the leader in blockchain news. I started the Consensus Conference, and I mainly program it these days. So some of you may have been in New York a few weeks ago. And I was a reporter in the space for a long time, but now I'm on the business side. So your secrets are now safe with me. I'm going to start with, and we'll keep this a punchy 20-minute panel, where hopefully I can put the panelists on the spot a little bit as well. I'm going to start with a quote from Peter Thiel, everyone's favorite iconic VC figure. And he said something very interesting at the intersection of AI and crypto. And he said, crypto is libertarian and AI is communist. And I wonder, since you all are at the the intersection of these two fields, how you interpret that and whether you think there is any truth to it.
This on? Oh. I think what it means, I don't know if it's a true statement. I think there is something wrong there. But what he says is that crypto should be accessible for everyone, and AI should be deployed in the benefit of everyone. Which is obviously not how the world works today. So that would be my short version of it.
Mm-hmm.
Hello. My interpretation of that would be that to train AI, you need to have a lot of data, which means that you're giving up all of the data, and there's like an all-knowing being that's kind of acting in the service of the collective. Whereas with crypto, it's kind of privacy first. For a lot of use cases, you have your own keys. You can be anonymous if you want. The privacy technology is still pretty early, but it's making strides really quickly. But I think ultimately, we make the decisions of what's private and what's public. And like with the graph, we're focused a lot on public data because we think that there's a lot that people need to be able to coordinate on. There's a lot of things that are shared, like marketplaces. You can't participate in a marketplace if that data isn't public. But things that are personal, how you choose to spend your time, for example, that absolutely should be private. And so that's where I draw the line.
So if I can offer something to flesh out that analogy, libertarianism and communism have things to say about how property is governed, right? It's all about ownership, who gets to own what and how that's distributed, which I think is kind of what we're talking about here in terms of data marketplaces and how blockchains play a role. So anyway, I just wanted to add that dimension there as well in terms of talking about this Peter Thiel quote.
Yeah, I guess it refers also to kind of the existing state of the world, which is that if we look at most successful deployments of AI, these are very, very large centralized bases and guarded by large companies. I think that is kind of a reflection of the technology status as it currently stands. I mean, there's obviously, and machine learning itself is not, deep learning is a subset of machine learning, which obviously requires very large data sets and all of these kind of things. Machine learning has a lot of value in lots of other contexts in situations where you don't necessarily need massive amounts of centralized data. So from that point of view, I think it's more of a reflection of the current state rather than the direction we're moving in.
And since you all are building companies and ecosystems in the space, I wonder if it's also a little bit of a reference to what you were mentioning earlier about gatekeepers, right? To kind of big AI, because you get out with a PhD. Where do you go, right? You go to Facebook, Google, or Amazon, or one of those labs, or you try and do a startup and sell to one of these folks. Versus, I'm just wondering, how does that paradigm compare to your experiences in terms of hiring and recruiting in the blockchain space? And this is all open source.
Yeah, well, obviously they are a huge attraction for talent in that area. I think having said that, in terms of the kind of social good and progress, there are certainly issues with any kind of centralized authority that has access to lots of data and has interests that are not aligned with its users. So I think in terms of if you have ambitions for the social good, that's one area which can motivate people to come into the decentralized ledger technology. I think what also is true is that the intellectual challenges that you face in this domain, which are to do potentially with economic questions, deployment in the real world, those are not necessarily the kind of problems that you're solving necessarily at Facebook or Google. So.
I see Web3 as kind of being like a battle between individuals. Maybe you can think of them as like renegades and like the big, corporate titans. And I think that battle is both fought for users and also fought for like employees of those companies, right? You can work at a big company like Google and have like, a very, very narrow focus. And personally, I've worked at big companies. I've worked at small companies. I much prefer the freedom of small companies and the quality of work that happens when it's a small team that you know really well. Decisions can be made really well, and so right now a lot of the power is concentrated in these really large behemoths. But I think developers who are building these things, they get to kind of decide: would I prefer to have freedom and be able to like switch between interesting projects, work on what I find interesting, not have a boss tell me what to do, and be able to jump between projects and be able to carry your work across with you between those projects? Or do I want to work on something that's closed source? As soon as I walk away from that, all of my work's kind of there. I don't get to take it with me. And I think that applies to code, it applies to relationships, it applies to the data. And so ultimately, I think if you believe in that kind of sovereign individual direction for the future of work, that people are going to choose the autonomy, then I think it would go in that direction.
Sovereign individual versus the Cosian firm, right? Yeah.
If you had one wish, you obviously wish for more wishes, right? So in that respect, I would say that if I would have one incentive to work on it, then it would be to create my own incentives. And that's kind of what you can do with this Web3 space. You can create communities that drive their own economies. They create a demand and an ask side, and it's basically this open economy that you're playing with, and decentralized governance around those algorithms can emerge. I mean, it's up to everyone to start looking at like, how can I play with this in my free time? Learn to understand what it means to program not with digital objects as such, but digital objects with value. We're talking opinion, we're talking shares, we're talking equity, we're talking everything up to incentives. And that's just a new programming paradigm. It's also a new way of constructing your economy. So I think that's not something that you can find in more classic, well, not classic, but your Web 2.0 space.
I mean, I don't want to touch on something you mentioned earlier, Yaniv, which is the competition for users, right? Because if you talk about decentralized data economies or marketplaces or users having greater control of their own data, you don't necessarily need to do so in a decentralized way, right? And one example of that would be like Apple's initiative now with sign in with Apple, for example, right? So I guess my question to you guys is, as big tech becomes aware of market demand for user control of their data, is there still a reason for decentralized data ownership, right?
I think you're right that as these problems become more kind of mainstream, these large companies are going to have to like compete, and they're going to do it by trying to maybe create more public APIs, things like that. But the problem with this kind of thing is that it plays out over like these long time spans. Like we started giving these Web 2 companies our data like 10, 15 years ago, and I don't think like the collective woke up to the fact that, oh crap, this is a problem until like the last few years. And so, they can do it again, and it might be another like 10 years before we realize again, oh crap, now like they changed the rules again. So they always have that ability, right? They can assuage us, and they can tell us, hey, here's an API, and then they can revoke it overnight. And so you never really have that solid foundation until you can prove and you have guarantees that power that they have can't be abused.
I mean, what I'd say, you always have the Kronos effect, which is the kind of incumbents have a real interest in preventing, the insurgents from supplanting them. And one of the ways they can do that is by crushing them or aping them in some way. The fundamental issue, though, is that their incentives are fundamentally disaligned from their users, which is that they want to monetize the users, whereas the user has a different set of incentives. So I think whereas they can, obviously, they try and meet the needs of their consumers, but there's a fundamental disagreement between the demands of the consumer and the demands of those intermediaries. And yes, I mean, I think it's great that they are taking more account of privacy, but I think in the longer term, it's an enormous threat to them and their business models and I think in the long term, the question is why should they exist in this world?
Structurally, it's just there's a structural problem. They can't do both of these things simultaneously.
Yeah. Well, there's a huge amount of unrealized potential on personal private data that we as consumer don't see what that unrealized potential is, and then you have like these ad bidding markets and etc. Associated services around that. It's actually the reason, a big part of the reason why I entered this space in 2013 or something when we started Ascribe, and it was just about protecting creators on the internet to stamp their creation as a license on the Bitcoin blockchain. And then we created a secondary tool, which was, I think, the cooler part. For the visual things, we would have like a reverse image search, so you could see, and the website was called Where on the Net. And then you would drop in your image and you would see how it spread over time over the web, who's using my images, my creations, etc. And then you could see like, oh, is this going viral because I still have ownership of title because I proved that I put it on immutable ledger. So creating strong provenance is something that helps us fixing the internet, which is currently broken by just linking forward and there's no backward attribution. So it's meant to spread, it's not meant to attribute. If we can do that attribution, that's kind of the first step, then we can start thinking about owning our unrealized potential of data.
Another element to this is I feel like just from a practical standpoint of trying to implement this, I don't think that you can reliably solve the integrations and synchronization problems with point-to-point APIs. So before starting the graph, or before our previous startup, I worked at a company called MuleSoft, which does API developer tools for enterprise. And the integration market is a really big market for large enterprises. And it's a really tough problem because just synchronizing data in a reliable way is difficult. And so even if each company has a public API and but they're all on top of like these Web 2 style APIs, and you try to use something like a Zapier to like interconnect these different services, you're going to have these same kinds of inconsistencies, data going stale, service becoming unavailable, and that failure propagating to affecting all of the different services.
Because it's like a Rube Goldberg machine eventually, right? Where you have all these APIs hooked up and you have to keep track of all the documentation.
Yeah, the complexity grows exponentially. And so I think that if you try to solve the problem the right way, to say, we want to have hundreds of thousands or millions of like different services that can all talk to each other reliably, I think you just need to do that with better abstractions, and basically immutable data is like a core part of that. And these protocols that people are building now are really kind of taking that approach. And so it's more than just who's controlling the servers, it's also just about what those primitives are for building those APIs.
I have two more questions for you guys. One of them is, in the world cryptocurrency, for example, everyone has read the story of the guy in Wales who had 500 bitcoins on his old computer, but he threw it away and his private keys were there. So if we're in charge of all our data, how the heck do we, keep it safe, secure, and managed?
Well, you just point to an interesting service market, right? We see a lot of there's. Wait, I just installed the app. These guys are Argent, having your peers as co-custodians, so you can lose a few of your friends, and then you're still good. I don't know. People it's going to be a service. It's either a community service or it's an outsourced custodianship. I think that's definitely we're used to having a data custodian anyways, but we just don't have any kind of incentive back to us. So I think that's not going to change too much. It's going to be more transparent.
Any thoughts from?
Well, I mean, it's not an easy challenge to solve initially, but I think it is a solvable issue, like Dimitri says, I think the kind of social key management or a custodian providing that service is a reasonable way of solving those kind of issues.
Yeah, I think that'll be a good solution. I think biometrics as being also like an interface for accessing keys that are stored in like a secure enclave or something in the hardware chip. I think we're on the way to solving those kind of UX problems. And the thing that's exciting here is the fact that we can solve them because they're all on top of these open APIs. If you've got like a system like your cell phone number gets SIM jacked and you lose access, you're kind of at the mercy of what T-Mobile or Verizon's policies are. Somewhere there's a 200-page manual where they have to follow all of these rules, and how do they even create those rules? You don't know, and there's no chance you're ever going to be able to affect them.
But if we're all saying we'll have private key custodians, aren't we creating just a new class of intermediaries?
Yeah, but it's on top of these open protocols so they can compete. And if you don't like how theirs works, you can create your own.
Yeah, exactly. That's a cool thing. And Global Coin will solve it all, right?
Yeah, we're all eagerly awaiting that. And I think we're almost out of time, but just very, very quickly, this stuff, decentralized data ownership is like a complicated topic. So very quickly, if I asked you to explain to somebody on the street, what's the upside, what's the benefit of that, how would you pitch it?
For me, it's really data portability. So being able to access all of your data from any application, that the data is yours. And so being able to have hundreds or millions of apps, being able to create your own app and have it be fully kind of customized to however you want to interact with your data, you'll be able to do that.
Okay. Dimi, your pitch?
I guess you could say we're in a service push in our face. And now with this, you create your little magnet, your service pool, and it's going to be fine-tuned towards your fingerprint. It's going to be nice.
Yeah. I mean, I was going to say a similar thing, which is that obviously your data represents you and your preferences and unique things about you. And potentially we can build applications that actually serves those preferences much better than aggregating information from many other people in these kind of centralized.
Gosh, I've heard that pitch before from a company called Facebook.
Really?
Yeah. Anyways, thank you all for sticking with us. That's all the time we have, and thanks to my panel.